So today we have Modules 3 and Modules 4 to do. Module 3 is on analyzing errors with the debugger. Yesterday we focused more on stepping through an application and using the debugger to analyze the code in the application. So the focus is going to be slightly different today because we'll be focusing on analyzing error conditions. We also have Module 4, which is on miscellaneous tools and considerations. Some of the miscellaneous tools are integrated with the debugger, things like being able to set your debug level or connect to a running application with the debugger, that type of thing. And some of the miscellaneous tools are not directly related to the debugger at all, but they're useful to know for debugging purposes. So our module topics and objectives for the first chapter. Topic 1 on analyzing logic errors. We're going to learn to use the debugger to locate, analyze, and test solutions for application logic errors. And topic 2 is just a very short topic on fatal errors. So you can use the debugger to quickly find the source of fatal runtime errors. And we talk a bit about what happens when you get a fatal runtime error in the debugger and outside of the debugger. So if you're just running an application and you get a fatal error, what kind of messages do you get that might be helpful? And then if you're in the debugger, what kind of messages do you get that might be helpful? Debugging logic errors. Talking about a lot of the things we discussed yesterday comes into play, of course, when we're ready to actually use the debugger for error conditions. All of the things we learned about breakpoints, navigating in the debugger using the next, continue, the step in, the step out of the functions, aborting, all of those, of course, play a role in debugging logic errors. The data view, the breakpoints view, code structure view, command view, all of those things we'll be using today, just as we did yesterday, to learn to analyze an unfamiliar application. So this time we'll take what we learned yesterday and use that as building blocks, and on top of what we learned yesterday we'll look at things like conditional breakpoints, watchpoints, and conditional watchpoints. So you'll learn what the differences are between a breakpoint and a conditional breakpoint, the difference between a breakpoint and a watchpoint, and then the difference between a watchpoint and a conditional watchpoint. So there's some new terminology and some new things to learn about breakpoints and watchpoints today. We'll also look more at the interrupt command. You learned about the interrupt command yesterday when we're working with an application that's running and it enters an interactive instruction. Remember, it turns control over to the interactive instruction, and through that, of course, it turns control over to the user. But we can use the interrupt option with the debugger to get control back to the debugger. For example, to quickly scroll to the correct line of code in the code editor to see exactly where we're at in the code. So that'll put us in that dialog when we enter an interactive dialog. But we'll learn how to use the interrupt option as well for analyzing logic errors by just using the debugger to navigate to the spot in the application where we're having problems. Perhaps it errored out, failed the previous time. We can navigate very closely to the point where it fails and then use the interrupt option there to put us into source code and allow us to study the environment close to where the program is failing. So it's a good way to quickly go to the right place in the source code for the failure and then start your debugging session from that point. We're going to look at these up and down commands. The up and down commands allow you to trace back through the function calls that get you to a certain point in the application, and as you move through the list of function calls with the up or down, it actually uses information in memory so that you can see all the settings for variables at the point when the function was called, even if it's a function that was called 2 or 3 functions back from where you currently are in the program, all of that information about the function call is still in memory, and you can access that using these up and down options. You can also see quite a bit about the functions that the program has executed through using the Backtrace View, which we've already looked at briefly yesterday. So we'll be using that Backtrace View again today when we're working with these up and down commands. They're tightly related. You actually can see the up and down and use the up and down in the Backtrace View. We'll also learn how to change variable values in the data view. We've talked about that, but today, if you work on the lab, there'll be a point in the lab where you'll actually change a variable value in the data view to see how that change impacts the program execution, how it changes what it does. Conditional breakpoints. So yesterday we talked about regular breakpoints. And if you remember, a breakpoint is just a marker that you can add to a line of code. You can put it right there in the gutter of Code Editor. And the idea is that when you run the application in a debugging session, it's going to stop at that line of code that's been marked by this breakpoint. Very arbitrary type thing. Doesn't have anything to do with the conditions of the application or the state of variables or anything of that sort. It's just an arbitrary point in the code that you want it to stop so that you can study the source code, the values of variables, and that type of thing for debugging. Well, a conditional breakpoint is different because you actually add a condition to the breakpoint that determines whether or not it does actually stop. So you can see from the example, if p state equals 2, now this breakpoint on line 98, looks like they're just getting ready to add this condition to this breakpoint on line 98, it may or may not stop next time we execute the application and it steps through that line of code based on this value of p state, this variable. So that's a conditional breakpoint. Sometimes the application will stop there at that breakpoint depending on the state of that variable. Other times it'll go right by it. So that's a conditional breakpoint. Let's take a look at one of those. We'll use our account application that we were working with yesterday. Pop over here. This is the, if you hover over one of the tabs in Code Editor, you can see the name of the module. So this is the account form _ UI.4GL module that gets called when a function is called here in the account.4GL module. So there's an area here, if you worked on your lab, that you're pretty familiar with, this function account form UI _ UI automaton. So I'm going to pop over to that, and I already have one breakpoint on this function from previous things that I've been doing. And I'm going to go down to this case statement where it starts this while loop with a case statement. So the idea here is that while the user is in a dialog and selecting options from the dialog, search, accept, modify, then there's a function then, it sets a variable called else state, or it passes in a variable that gets assigned to this else state variable here in this function, and depending on the state or the value of else state, it determines which one of these case statements is selected, and then of course which function in the case statement is actually executed. So I'm going to put a breakpoint right here at line 149 where it starts this while loop, and we're going to stay in this while loop for the duration of while the application is in this dialog. And then I'm going to put another breakpoint right there where the case statement starts, just so that we can tell whether or not the breakpoint should start or should stop or doesn't stop based on the settings for this else state. So I've got these two breakpoints set, and I've got one up here. So let's go ahead and kick off this application in debug mode. Let me respond to that prompt. So here's my accounts. Pop that up there for just a second. So here we are getting started with that. I'm going to kind of put it down here out of the way for just a minute. So here we are at this first breakpoint, this account form UI automaton function. If I go ahead and click continue, of course it's going to stop at this breakpoint on 149. If I hit continue again, it continues and it stops at the next breakpoint, just as you would expect with a typical breakpoint. If we look at our data view down here, here's this value of L state. So that's the variable that we're going to be watching for these experiments with breakpoints and even watch points here in a few minutes. So here's L state, and currently L state, the value is set to 1. So if we were trying to predict what this case statement would do, which function it would process, we can look at that L state value, because that's what the case statement is evaluating, case L state. And if it's set to 1, we can see that that evaluates to this constant C mode display. So 1 is C mode display. So we would expect it to enter this when, this part of the case statement right here. So let's see if it does. We'll just do a next. And sure enough, it pops into the C mode display block, and then it's going to execute this function call. So let's go ahead and run do one more thing here. So I'm going to go ahead and click next. And when I click next, notice that we've got the pause symbol or the interrupt symbol up here is highlighted, which tells me now that it's entered an interactive instruction. So I'm going to pull up my form so that we can see where we're at here in the form in this interactive instruction, and I'm going to click the search option. So I've clicked the search option. Right now it's just sitting there in limbo waiting for me to do something here, and again notice it's starting to execute code and it's stopped at the first breakpoint there on 149. You drag this up so we can see. Notice the state of L state, or the value of L state, has now changed to 4. And if you look at your lab from yesterday, if you got this far in the lab, you notice that a 4 evaluates to the constant C mode search. So if we look at our case statement, C mode search is down a little ways, right here on line 167 in my interface, in my code. So I would expect it to go ahead and run the function there in that C mode search. So let's just see if it does. So now it's stopped at the next breakpoint on line 150, and sure enough it goes into this when C mode search block so that it can execute the proper function. It's going to be a UI construct function call. So that's what we would expect it to do. So if we look over here on our breakpoint that we have, let's change this and add a condition. So this time we're going to use about the same thing that you saw in the example on the PowerPoint, if L state equals 2. And it's not very picky about formatting. You can put the spaces in, you can take spaces out, but with the equal around that equal statement, and I don't think it cares very much. It's easier to read if you put in a few spaces, but it's not mandatory. So I'm going to click OK, and now I have a conditional breakpoint. I've got this if L state equal 2 here. So now the only time that it should stop at this breakpoint, I'm going to scroll up just a bit here so you can see it, this one on 150, is if the value of L state equals 2. So if it's 4, if we're doing something like a search, then it ought to skip right on by that particular breakpoint. It should stop at 149, but it ought to skip over 150 until we do something. 2 is modify, right? So that evaluates to C mode modify. So now let's see what happens. Let's try it a few times. So I just clicked continue, so now it looks like we're back in our interactive instruction. So I'm going to hit interrupt to put us back there. So I'm going to accept. Right, a few minutes ago when I was in here, I did a search, I believe. So now I have to hit accept so that it can move out of that. Let me hit continue. And sure enough, here we are executing code. Stopped at the first breakpoint while running automaton. And if I click next, notice it skips right over that conditional breakpoint now at line 150. So it didn't stop here because if we look at our data view, the value of L state is set to 1 right now. So 1 is the C mode display, evaluates to that constant C mode display. And our conditional breakpoint is looking for a 2. So it worked just fine, right? We stopped at the first breakpoint, the one on 149, which is not a conditional breakpoint, but we skipped right over the breakpoint at 150, which is looking for a special condition for that L state variable. It has to be 2. So let's go ahead and continue on. We're back in our interactive instruction. Notice we have the interrupt is enabled and everything else is grayed out. So I'm going to hit interrupt to put us back in that dialog. And so this time I'm going to select modify. So I have a record from the database up here. I'm going to click the modify option. So now I'm going to hit continue. Here's my first breakpoint at 149. Let's check the value of our L state variable. And if we look in the data view, notice it's now set to 2. So this time it should stop on 150, line 150, where we have the conditional breakpoint. So I'm going to hit continue. And sure enough, it does. So if we look at our breakpoint, notice now that our hit count has been incremented to 1 because it's finally reached this condition that it's looking for, so we finally incremented our hit count. Any questions about that? So far, so good. If you have any questions, feel free to use the raise hand icon, for example. All is well? Okay. All right, so that's a conditional breakpoint. This slide is talking about watch points. We talked briefly about watch points yesterday, but if you remember, the difference between a breakpoint and a watch point is that a breakpoint is going to stop arbitrarily at a specific line of executable code, right? A line of code that you have placed the breakpoint on or associated that breakpoint with. A watch point behaves differently. It's still going to stop like a breakpoint would, but it doesn't stop arbitrarily at a specific line of code. It stops based on the value of an expression or when an expression changes. So think in terms of a variable. So if I tell it to watch a specific variable like L state, then when the value of L state changes, that will trigger the watch point so that it will stop executing the code. So that's the difference. Breakpoints stop every time we get to a breakpoint, unless it's a conditional breakpoint, and they stop at an arbitrary spot in the code just because you have a marker there. But a watch point doesn't stop at a specific line of code. It stops based on a condition wherever that condition has taken effect, whenever that variable changes value, essentially. So to set a watch point, let's pop back in here. We'll just walk through this process. Let me go ahead and move off of our breakpoints here, and I'll get rid of these. So now I'm just going to remove these 2 breakpoints so that we can tell if our watch point is working. So instead of using a breakpoint to stop at a specific line of code, I'm going to use a watch point. Have to move stuff around here. I've lost my... So here we've got our watch points. Notice right now we don't have anything in our watch point view. It's completely empty. So to add a watch point, I'm going to go over here and look at my data view. And here's all my variables that are currently in scope. So I'm going to take this else state and right-click on it and say Add to Watch. So now if I go over to my Watchpoints view, I have this new watchpoint, else state. It's not a conditional watchpoint at this point, but in a few minutes we'll look at conditional watchpoints. First off though, let's just look at a regular watchpoint. So there's our watchpoint, and now it should stop program execution when we're doing a debug session anytime the value of else state changes. And it doesn't matter what it changes to, just any change. So let's go ahead and continue on here. We'll go ahead and hit continue so that we can get into our dialog or interactive instruction. So now I'm going to hit the interrupt to put us in that dialog, the right line of code. So now we're in the dialog, and I'm just going to do something here, and just by doing anything at this point it should change the value of else state eventually when it calls that function. So I'm going to use, how about search? So I hit search. I'm going to go ahead and continue, and notice here it's stopped at this while loop, and if we look at our watchpoint, it says expression else state new value 4. So it did trigger this watchpoint because the value of else state has changed. So our watchpoint is working. It didn't stop us at a specific line in the code. It stopped us because the value of that variable changed. So let's try a conditional watchpoint. We don't want it to stop every time the value changes. Let's say we do just want it to stop when else state changes to 2, very similar to our breakpoint example. So I'm going to go into our watchpoint. I can add a condition to my watchpoint, and it's the very same way. If else state equals 2. So now I have a conditional watchpoint. So again, it should stop at any point in the code where that value else state changes, but only if it changes to 2. So let's experiment a bit with that and see if it works the same way the breakpoints did, the conditional breakpoints did. So I'm going to continue here to get us back into our interactive instruction. So hit our interrupt, and that'll put us back in our dialog. So first we'll do something that is not a 2. We won't do a modify. That's what a 2 is, C mode modify. So here we're going to do an except. You know, I just realized one thing we need to do, because you won't see this, it'll go right by, right, with our watchpoint. Since it's not going to meet the criteria for our watchpoint, it's going to fly through here and you won't even see it. So to make sure that doesn't happen, I'm going to add some breakpoints in here to stop it. Whoops, I'm in the wrong place. Let me pop over here, is what I'm talking about, in this while loop. So and that's about all we've been using is display, modify, and search. We haven't done any adds, so I think that'll be good for what we're working with here. Okay, so now I've got some breakpoints, so at least you'll know that it's gone through this function and through the case statement. Okay, so now I'm going to hit continue. There we go. I wanted to make sure I had the current line up before I hit continue so you could see it move. So I'm going to hit continue here. So we're back in our interactive instruction. And let's say I pick accept. And it's a good thing we did put in the breakpoints, because notice that it went right by where we changed the state or changed the value of else state, because notice that if we look in our data view, the value of else state is not 2, which is what our conditional watchpoint is looking for. The value of else state is 1, so it did not trigger the watchpoint, and it went right on into the case statement without stopping. So it stopped here at our breakpoint, but the watchpoint that we set is not activated. So I'm going to go ahead and continue through. Oh, I wondered what had happened. I had an error there. Well, I didn't really have an error. Notice what the message down at the bottom says. It says that I've been running my application too long. These temporary keys that we're working with in class, they have a time limit for them, and if you leave your application running too long, it actually kills them because they're temporary. It's an evaluation copy. So that threw off our demo a little bit, but we can get right back in there. It won't take but just a second. All right, so I'm not sure exactly where we were, but one thing is for sure, if we look at our watch points, remember watch points don't persist. So we've lost our watch point here. So that means we'll have to reset our watch point. We talked about that yesterday. Breakpoints, they hang around. They're private, they're per user breakpoints, but at least they persist over sessions, debugger sessions, but watch points don't. So let's see here. Let's go ahead and we'll recreate our watch point real quickly. So I'm going to click on that L state and say Add to Watch. I'm going to go over to my Watch Point tab and reset my condition. And our condition was if L state equals 2. Put that back out there. So now we should be good to go. Let me just check, make sure we still have. All right, we still have these breakpoints. Okay. So just to get us rolling again, I'm just going to hit continue because I'm not sure exactly what we've done before we got this far. Okay, so we just went through, if we look at our data view, L state is set to 1, which is display. So it skipped right over our conditional watch point and it entered this swing C mode display block to execute this function. So now I'm going to go ahead and continue again. That gets us back to where we're ready to go back in our dialog. This time I'm going to click Modify. And this is when we timed out, I think, last time. So now I'm going to hit Continue. And notice this time our conditional watch point did take effect. So we stopped before the breakpoints that we have here in the Modify block of our case statement. So if I click Continue, that's where it goes. All right, so that's a conditional watch point. It took us a few tries to get all the way there, but eventually you saw it. Any questions? So far, so good? So again, if you have any questions, feel free to send me an email later, or you can always use the chat interface as well. So we've looked at watch points, we've looked at conditional watch points, and we've looked at the interrupt command. So we're familiar with the interrupt command so that we could pop back or scroll quickly through the code in Code Editor so that we could see the dialog instruction that's currently in effect or is current. But you can also use the interrupt command for navigating to the right place in the code if you're getting fatal errors, and you can use the interrupt command at that point to give control back to the debugger. And of course, we've noticed when you click that interrupt option, it finds the place in the source code that's the current executed statement. So that's very handy when you're debugging errors. You can navigate with your next and continue options until you get close to where you know that the error keeps occurring. And when you get close, you can go ahead and hit that interrupt option and go right to the line of code that's convenient. So it makes it quick and easy to go to the spot where you might be having troubles with an application. This is talking about the Backtrace View. We've talked about the Backtrace View some already, but this is a good place to revisit that. If we look at our Backtrace View right here with our demo program that we're using, you can see here that we have gone a long ways into the application. We started out here at this outermost block, which is main, and we're just gradually working inward into the application. They refer to the main, in this case, as the outermost function. So here we can see we started out here with this main when it called this function account open first form on line 48, and then account open first form in turn called this account form UI open form. And notice at that point that we had to open an additional module. So if we're in a debugging session, of course, that automatically opens that source module and puts us in the proper line of code. It put us at line 50 at that point. One thing you can do here in the Backtrace View, if you're curious about seeing the state of variables, seeing the executable code that was executed, you can explore some here in the Backtrace View. So if I click on this, double click, notice I get this arrow and I go right back to the line of code where it called that next function, that account form UI automaton. And I can just keep doing that. What I'm actually doing is, if you look up in here in the toolbar, I'm doing an up or a down. And I'm about to confuse you greatly because it's just the opposite of what you're going to expect it to be. So notice that when I click up, look what happens in the Backtrace View. I'm going to click up. We go down in the Backtrace View. So it's confusing because of the way that the Backtrace View displays the list of function. But essentially, going up is traveling towards the outermost function call. So it's heading back towards the main, our entry point into the application. So it's just backwards looking because the Backtrace View shows it from the bottom up instead of the bottom down. So it's hard to keep straight, but up will actually move you down in the Backtrace View because it's working towards the outermost function. But I can also work my way back up, and notice as I click on the up button to move back up, I'm moving back up in the Backtrace View, and my data view, let me click on the data view, is changing. So I'm going to click down to go back up in the Backtrace View. There we go. And notice as I do that, the values of my variables are all being reset to what they were when that function call was made. So that's a way that you can backtrace through the application and see variable settings, source code that was executed by navigating through these list of functions in the Backtrace View. Gives you a lot of information when you're trying to figure out how you got to a certain point and why the settings are like they are and when they changed. You can use this Backtrace View and the up and down arrows as well. Really, you're just doing the same thing, moving up and down with these, or you can just double click on them in the Backtrace View. This information is coming from an area in memory that keeps track of all of these stacks for these functions. All the information about them is kept in a memory area, and it will stay out there until the function returns back to the calling function. So for example, all this information I have here for account form UI automaton is available to me until it actually returns back to the calling function, account form UI open form by key. And when it does that, then I lose my stack information in memory, so it's no longer accessible. But these will gradually go away. All this information will go away as these function calls return back to the calling function. So that's the Backtrace View and the up and down options that you have. So here it's talking about the function calls using the up and down. This go to frame Let me just show you that, because if I don't, you'll think you're probably missing something. But if I just say go to frame, let me click on one of these that's farther away. Essentially, it means it's going to grab that frame in memory, the information for that function call, go to that line of code in Code Editor, and then update these variables so that they represent the function call when it took place. So really, you've already seen that. It just has a slightly different terminology it's using for it. And then here's changing variable values. We've talked about being able to change variable values, but this is a good time to actually do that. I'll hit continue. Put me back in my dialog. And I'll do a search just to do something here. Hit continue.
Now you probably need to set a breakpoint at the case statement or something.
I might have to, because it's not. Let me pop it right out here. I'm going to pop over here and do it. That ought to be a good place to do it. All right, let's see what happens now. Pull that up. I'm not where I can set it yet. Right. Click search. Continue. So now it should be stopped there, and we ought to be able to change that to a 7. I'm going to do a next so we can see where it's going. Okay, else state. That's better. Not sure exactly what I did. I must have been in just the wrong place, as you said. I must have already been in here. But here it's in C mode exit app, and so now it should go ahead and execute this function and exit the program. There we go. That took longer than it should have, but you get the general idea, right? You can actually change the values of variables, and providing you're in the likely place for it to take effect, it will. So topic 2 is a short little chapter on analyzing fatal errors. There's just a slight difference between what happens when you get a fatal error inside the debugger, when you're running a debugger session, and whenever you encounter an error just running a program, for example, in Genero Studio, between the type of information you get. If you're running a program outside the debugger and it fails with a fatal error, you get an error number and a message on the screen. If the fatal error occurs in the program in the debugger, you get that information, but then you also get a line number and a statement in the source where the error occurred. So I can show you that, I think, pretty quickly here. I introduced an error this morning in a different application. I didn't want to mess up our main application. So let's just execute it outside of the debugger first. So I need to do a query. Then I'm going to do a modify. And it failed. So down here at the bottom in my output view, notice I get a SQL error statement, error number such and such, not in transaction. So I get some information about it. If I do it inside the debugger, let me just clear this out and do a debug session on it and do the same thing. The information is slightly different. So then, if we look at our output view, I have just a bit more information. I've got the error, and then I've got not in transaction, program exited with such and such code, and then I've got the line number that it was on, 295, and then the code that it actually failed on in function. Not extremely helpful, but at least I know the general vicinity where it had a failure. That would give me at least a starting point that I could use to find the problem. So just a very slight difference between using a debugger with a fatal error. You can use the debugger features to trace the program flow up to the point of failure, but once it fails like that, there's no way to get back in and continue the session from where it left off. So really what it's saying is you can't really use the debugger to trap a fatal error so that it doesn't fail. You just have to try to figure out as close as you can to where it did fail, and then try to add a breakpoint or use your interrupt option short of where it failed so that you can explore the problem. The last chapter, Module 4, is on miscellaneous tools and considerations. Here we'll look at some topics that have to do with the debugger, and we'll also look at some topics that don't relate directly back to the debugger, but do have something to do with the debugging process. For example, we have the code analyzer that we can use to reverse engineer an application. There's a couple of diagrams that come with the code analyzer that we'll look at. We can also use the profiler to locate program bottlenecks. It has two pieces of output that you can use to see more details on where your application is spending the most time. And then topic 3 is miscellaneous considerations, just various debugger commands, methods that you can use for debugging, and some environment variables that you might want to set to increase the amount of information you see in your output. So topic 1 is on the code analyzer that we can use to reverse engineer an existing application. There's two different diagrams that you can use with the code analyzer. There's the dependency diagrams that show you the relationships between the applications, and the sequence diagrams that shows you the relationships between the functions and how they interact. First, we'll take a look at the dependency diagrams. To get into a dependency diagram, you just right-click on an application node or the project node. So if we take a look at our accounts application that we've been working with this week, and we right-click, there's an option here to open dependency diagram. So here we have a fairly collapsed dependency diagram. You can collapse it further if you right-click on the diagram and click Collapse. And there you can see we've got a completely collapsed view of the entire Office Store model. If we right-click again, we can expand it and get back to where we were, where we can see our accounts application and the main module, or the module that contains the main program block, in the diagram as well. So we can right-click, and there's an option here to filter items. So if we want to see more detail in our dependency diagram, we can click that, and we have the filter view. So here in the filter view, I know that I do have some modules that have functions that are used with our accounts application in this entities library node. So I'm going to click on this checkbox next to the entities node and click OK. So now I've added this entities node to my dependency diagram. And if I right-click again, I can see I have the option to expand that node. So I'm going to click Expand, and you can see now that we have a fully expanded diagram of our accounts application. Now here it also contains some modules that don't directly relate back to this accounts application. Now at some point in the diagram you can see that they're related to modules that are associated with the accounts application, but we can filter out some of these modules so that our diagram isn't so complicated if we right-click and click on Filter Items again, I can just go through here and look for modules that I know that I'm not specifically interested in right now. So just to show you some of that, I'm going to click on some of these to remove them from the diagram and simplify it. So you can see you can right-click and go into this filter view anytime you like and re-add some of these modules if you want to take a closer look at them, or go in and refine it further and simplify. So that's a pretty simplistic view of our account application here. So that will work for us. So here we can see a list of the modules for the account application. We can see which modules are related to other modules by following the arrows. We have an arrow trail here that we can look at. So for example, we can see that the account module is related to the account form _ UI module. And we also can see those relationships over here in the structure view as well. So again, we have this tree structure on the right-hand side that we can also use. If you want to see more about functions, the functions that cause these modules to be related, you can click on one of the arrows and notice that you get an additional view down here at the bottom. We have a function calls view, and if we look at that function calls view, you can see that it's giving us information about the caller function in the module, the called function, and then of course the caller module here, and the called module. So we have information in our dependency diagram about the modules that are related to each other, and then if we click on these arrows, then we get information about the functions that create those relationships. Now if you right-click on a function, for example this caller function column, notice that you get some additional options. We have a symbol definition. If I click on symbol definition, notice that puts me in code editor right here at the entry point of that function so that I can see all of the defined variables. If I right-click and select this open call location, notice it again puts me in code editor right here where it actually calls that called function. So here's the function call. So if I want to take a close look at the code where that function call is actually made, I can use that right-click option. And I've got an additional option here to open the sequence diagram. So here's our second diagram associated with the code analyzer. So we just looked at our dependency diagram so that we saw more information about the actual modules and how they were related. And if you right-click and select this option to look at the sequence diagram, now notice that we're focusing in on the functions themselves. Now there's 2 or 3 ways that you can get to a sequence diagram. You don't have to right-click down here in the function calls view. You also could right-click over here in the structure view on a function, and you'd have the option there to open up the sequence diagram. And also if you're in code editor itself and you right-click on a function in the code, there's an option there to open the sequence diagram. So there's multiple places that you can get to this option to open a sequence diagram. So if you take a look at your sequence diagram, it's showing you your entry points into a module, the specific function that's used, and then you can see from that module, in this case account form _ UI.4GL, the function call that's made to create a relationship with an additional module, in this case account form _ UI dialog.4GL. And you can see here that these plus symbols, if you right-click on the plus symbol, you can open up the diagram further and see any additional subcalls contained within that same module. So that way you can follow the program logic within a single module by opening up these subcalls and taking a closer look there. So that's the sequence diagram. So we have our code analyzer. We have two different types of diagrams. We had the dependency diagram to take a close look at the relationships between the individual modules of an application. And then we had the sequence diagram that we can use to take a closer look at the function calls and the relationships between the functions in an application. So here we can see the expanding and collapsing the diagram. Notice that, like a lot of our other views that we've seen previously in class, you can use the control mouse wheel to zoom in and out. Sometimes you'll get a very complex dependency diagram that has too many modules to be able to see on the screen. So you can use the control mouse wheel to zoom in and zoom out. You can hold the key down on the mouse and move around in the dependency diagram so that you can move to different areas of the dependency diagram as well and focus in on things that perhaps you can't see in the overall view until you move around a bit. Here's the filter view that we looked at that you can use to filter out perhaps some modules that you're not interested in for the moment, and then later you can go back in and add those modules back in if you want to, just by right-clicking and selecting the filter view. And here we saw the structure view on the right-hand side that gives us our tree view, where we can also explore our dependencies between the modules and the functions if we like. And here on the bottom we can see that we have our function calls view that we explored earlier. There's also additional right-click options for called functions as well, so you can explore those right-click options too. And there's our sequence diagrams. We talked about the different ways that you could open up sequence diagrams. There's three different places: the code editor view that you can use to click on a function, right-click on a specific function, and you'll get the option there to open the sequence diagrams. We've got the code structure view, where you can right-click on a function in the code structure view, and you get the sequence diagram option there, and then of course the function calls view as well. Topic 2 is on the profiler, another tool that you can use to analyze your application. The profiler lets you analyze where possible bottlenecks might be in your application, or at the very least you can see where your application is spending the most time. Now, you would run the application as you normally would. You would just select this option you see here on the screen to execute with the profiler. Once you click that option, it looks just like the normal execution looks. You would go in and work with the program like you normally would. Choose, for example, search, modify options, maybe do some updates or add some data. And then when you exit the application, you'll see your profiler output in the output view. So we'll take a look at that here in just a minute. Now, it would take several iterations of executing with the profiler to really get a good overall impression of where all of your bottlenecks might be, or where your application is spending the most time. One iteration probably won't give you a very good overall view. So you do this multiple times, trying to emulate as much as possible normal use by your end users and try to get an idea that way. The profiler has two different sections. The first section is called the flat profile section. So you can see it's got a list of all the functions for the application, and then you can see all the details about the amount of time spent in this function. So we'll take a look here at the description for the columns, and then we'll go ahead and run the profiler and see what it says about our accounts application. So here the first column is % total, and that's the percentage of time spent in this function. And notice that that total, percent total, includes the time spent in subroutines called by this function. The next column is percent child, and that's just the time spent in the functions that are called from the function you're analyzing. Percent self is the percentage of time spent in this function excluding the time spent in subroutines. And then finally, the last column is just the name of the function you're looking at. So let's take a look here at our accounts application. If I right-click on my accounts application and I specify the second execute option with the profiler, let me answer that prompt. And then just use the application as I normally would. I'll do a search. Scroll through my results set. Maybe do a modify. And you can get the idea. You would just try to behave as a normal end user would. So I'm going to exit. Let me scroll this over where you can see. And here's our profiler output. So we'll go all the way up to the top here. And notice this first section of output that we've been talking about is called the flat profile. So here we can see a listing of all the different functions, and notice that a lot of these functions are not functions that we're familiar with. All of these RTS underscore function names are related to the runtime system. So those are more internal functions. Notice that we've also got functions that are actually methods associated with, in this case, adding items to a combo box. So even these methods that we're using from these built-in classes are referenced here so that we can analyze the time spent by those methods. But let's just pick one and analyze it. Here's one. Let's look at main would be a good one to start with. So we know that our main entry point into our application, notice it's got 100 here for the percent of total time spent in the function, and that's of course because everything is initiated from this main program block. So of course 100% of the time is associated with the main. And then we've got 99.5 up here in our percent child column. So 99.5% of the time is spent in subroutines called by this main function. And then the time spent in itself, of course, is going to be very small because 99.5% is spent in functions called by the main. So that one's going to be unique, the main. So let's look for one that's not the main to get a better idea. And again, a lot of these are going to be internal functions that we're not familiar with. How about this account form underscore UI underscore UI open form by key function? So if we take a look at that, so this particular function was called one time. Percent total time is 37.2. So that's the percentage of time spent in that function overall for the duration of us running that application. 37% of the time was spent in child functions called by account form UI UI open form by key, and only 2% of the time overall was spent in this function. So that's how you read this flat profile view. Gives you an idea of which functions use the most time. So you could just scroll through here looking at your total time column to see functions where you spend a lot of time. And of course that main's always going to catch your eye, but it's unique because everything kind of goes through the main, so you can't worry too much about that. But notice here's a busy function, this account open first form. 37.8% of time is spent in that function, but mostly in sub-functions or sub-calls that this function makes. And you can see some other busy ones. The one we looked at, this account form UI open form by key, is also a busy function as well. So that is the flat profile section. The second area of profile or output is called a call graph. So that's if you just scroll down past all of the flat profile output, then you'll automatically come to the call graph section. So it's just towards the bottom. So the call graph section for each function lists the functions that called that function, the number of calls, the time spent in the function, functions called, the number of calls, and then the time spent in subroutines. So that sounds fairly complex, so let's take a look at that as well in our accounts application. So I'm going to scroll down here past all the flat profile information, and notice here I come to the call graph area. So here in the call graph area, the first thing to notice is that the function that you're looking at has the 3 asterisks. RTS underscore SQL connect, for example, or get front end name. So that's the function that you're looking at call graph information for. So let's see if we can analyze one of these. Let's look at this RTS dialog wait. So here we're looking at this RTS dialog wait function. It was called 38 times. That's what this column is telling us. And this function right here, account form UI input, called RTS dialog wait 5 out of the 38 times. So RTS dialog wait was called 5 times by account form UI input. It was called 30 times by account form UI display, and then finally 3 times by account form UI construct. And then of course you can see the total amount of time spent in these functions, percentage of time spent in the function itself, and the percentage of time spent in the child functions called by account form UI construct, for example. And then down here towards the bottom underneath RTS dialog wait, notice the arrows are going the other way. That means that RTS dialog wait in turn called these functions. It called account form UI dialog rec account UI input 3 times. Notice this function was called 4 times overall, and RTS dialog wait called it 3 times out of the 4. And RTS dialog wait also called account form UI dialog rec account UI display 23 times out of the 26 times total that it was called. So that's the idea with the call graph section. So you get a good idea of exactly what these functions are doing, how they're interrelating with other functions, how many times they call these other functions, how much time it spends in these other functions, and so on. So that puts us in topic 3, which is miscellaneous BDL commands, functions, and other things, other methods that you can use to get the most from a debugger session. So a lot of these things are not directly related to the debugger, rather like dependency diagrams and sequence diagrams, but they are related to the debugging process. So far with our debugger sessions, we've been working with breakpoints that we add in the gutter, right? We can right-click on a line of code in the code editor and add a breakpoint. But you can also add breakpoint instructions. We actually have a breakpoint command. So you can embed the breakpoint command in the code, and it's a permanent addition then to your code. One difference here that you would see between using the breakpoint instruction versus just adding a breakpoint in the code, the red dots that we've been using so far, is adding a breakpoint with the right-click option is private to an individual user. So if you were to talk to another person on your team and they wanted to go in and run a debugger session on the same application and see what you're seeing, then you would have to tell them where to put the breakpoints, right? Or send them a copy of your macro, right? You could create a macro and send them the macro, and they could use that to rebuild the breakpoints. But this is another method where you can add the breakpoint command to the code, and then anyone that can share the code also gets these same breakpoint instructions. So they're no longer private, they're tied to the code. So very simple to add the breakpoint instruction. So let's add a breakpoint instruction to accounts.4gl. So I could use the option here to add a breakpoint to the gutter, but I can also just add it here. And if we run the application in a debugger section, and there we clicked query, and that stopped us then at this breakpoint. So very straightforward command. So here we're talking about this SQL-CA record. If you did take the Genero Language Basics class, you're already familiar with this global predefined record used by or defined by the runtime system. So we typically would use this SQL-CA.SQL code that you see here after any SQL statement to determine whether or not that SQL statement was successful or not. So that's typically how people use this SQL-CA record. They check SQL code to make sure that that's a 0, and a 0 is a successful SQL statement. Anything other than a 0, of course, is an error, a problem with the SQL statement. Now, depending on the database you're working with, you can also use some of these additional members of this global record to get additional information. The SQL-CA global record is proprietary, so you can use this with all databases using our open database interface to check the SQL code for success or failure of the SQL statement. But be aware that some databases don't support other members of this SQL-CA global record. So you won't be able to, for example, get details from some of these other members like SQL ERRD or SQL ERRP. You can get a full description of all of those record members if you're interested in them, and you do use Informix or DB2. You can get a full description of what those other members hold by looking at the documentation for the Open Database Interface. The start log built-in function initializes error logging and opens the error log file. So you can use start log along with this error log command to document your application so that as a user executes the program and moves through different areas of the program, perhaps querying or modifying data, you can actually track his progress and see how the program is used. And of course, the other idea for this is to add additional error information, customized. You can add customized error information to your log files. So I've added this error log function here to our accounts application. Let's go up here to the top where we first call start log and give it information so that it can specify the name of the log files. And notice we're just using the double pipe symbol here to append the first part of the name. We want to, in this case, put the log file on the D drive under the logs directory, and we're concatenating that to the process ID of the process for the application that's running, and then we're appending the .log to the end of that. So here you can see some of these log files. If you click on one, here that one was empty, but here the user has entered a certain area of the code. And right here I've got on action query. When the user selects the query option, I'm calling the error log using this function and just specifying a message, a log message of user queried. So that's why then in this particular log file, here it has the date that the message was entered and then the message that I specified with this call error log function. So here I'm tracking program use by the user in this case. So you could see how you could add messages to all the different function entry points or all the menu options as we're doing here, just to be able to log or track the way that users are using an application, what they typically do in an application and how often that they do it. So that's the start log built-in function and also the error log built-in function that you can use to customize your messages. And here's the get stack trace method that you can use to get the stack trace of a program. This is useful anytime the program fails. We talked about how during a debugger session that it wasn't possible then to see information about your function calls once it crashed because that memory area goes away when the application ends. You could use this to print out your stack trace information using a special method so that you could then look at the information in the output view. So typically you'll use this with the whenever error call. Like up here in the main, you've got whenever error call myHandler, and then we've got a function here called myHandler. And here we're just using this built-in application class method getStackTrace to print out a formatted list of all the function calls leading up to that point of the error. And finally, here we've got some environment variables that you can use for debugging purposes. We've got several of them here. This FGL GUI debug, notice you can set it to 1 to display your information between the front end and the runtime system, the GUI protocol exchange, they're calling it. You've got the FGL SQL debug environment variable that you can use to get more information about SQL instructions. And then we've got FGL WS debug that you can use to track exchange of data with web services applications. And then we have a GRE debug environment variable for report writer errors. If you're using Genero Studio, You can actually configure those. Some of them are already pre-configured. If I click on the wrench icon, I'll go up here and do it in Tools. Tools, Genero Configurations. I can click on that, and notice right here in my environment sets, I've got a debug environment set. So if I select that debug environment set, over here on the right-hand side, I've got all the environment variables defined for that environment set. I've got FGL SQL debug, FGL WS debug, GRE debug, and FGL GUI debug. So you can add environment variables or remove them up here with the delete option, the plus option, and so on. And notice there's a value of 9. All of these are predefined or preset to 9, which is the highest possible level. And of course you can adjust that value as well. You can edit and adjust it that way. But I'm just going to leave it there at the defaults and click OK. And now that I have that debug environment set selected, I should be able, let me stop this application and run it again. Now I should see a lot of additional information down here in my output view. All of this information just goes to standard out, which in Genero Studio is the output view. So notice you can see a lot of detail here. Here's actually all the information being loaded into a combo box. And as you maneuver through the program or navigate through the program, you would see additional info in the output view. So notice there's additional SQL information from that environment variable. So there's our environment variables, and you can adjust these values or you can remove these altogether if you like. If you're not interested in, for example, the web services debugging information, you could remove that. Not that it would put any output out there anyway if you're not working with web services, but you can see that you can customize these as you like. Before we talk about preventing debug mode in production, let's talk about first attaching to a program in production. One thing that you can do with the debugger now is attach to a running application. So let me show you how to do that. If you just, here we're doing everything locally, so let's run this application. Pretend for a moment that I'm an end user running the application. And up here in the debug menu, there's an option to attach to process. If you click on that, you can specify the process ID that you want to connect to. And notice that there's an option here for local processes, which is what we're using for class purposes. Or if you have a remote application server and your applications are running remotely, you have this option to connect to a remote process using SSH. So here we've selected this local process and I have this attach option. When I click on that, notice that I've now connected to that running application and it starts me up in the code editor with a regular debugger session. So I'm now in control of that application. So that may be something that you want to allow when there's a problem with a program in production. And of course you would typically start those debug sessions in a controlled way, not when you had an end user working with the program. But let's say that you're concerned about that ability and you want to disable it. That's what this slide is all about, preventing debug mode in production. There's actually an FGL profile entry that you can add to the FGL profile, FGL run.ignore debugger event =true. And that will turn off the ability to be able to attach to a running application. So if we take a look at that here in our Genero Studio environment, here I've got my FGL profile. I'm going to add a line here, this FGL run dot ignore debugger event equal true. And providing I don't have any typos in that, FGL run, and it looks good, then that should prevent me from being able to attach to that running application. I'm going to try to attach to that running application. And notice this time I get an error. Debug socket error detached. First it says attaching to local process. Then it says detached from process, connection refused. So that's the way that you can prevent then an application from being debugged in production mode. So that brings us to the last page of the last chapter in our debugger class for the debugger. If you'd like additional information on the debugger, you can see the Genero Studio help. Remember that there's a whole section on the graphical debugger there that you can read through and experiment with. And if you're interested in command line options for the debugger, don't forget that the Genero Business Development Language User Guide also has a section on the debugger that focuses more on command line options.